I'd like to close with an important note concerning the use of quantifiers in non-universal generalizations, which can appear in the premises of both inductive generalizations and statistical syllogisms. Any statistical syllogism will always have at least one premise that contains a non-universal generalization, and many inductive generalizations will also include in the premises such quantifiers as many, most, or nearly all. And as you know, these are non-universal generalizations which are derived from a limited number of observations, which statisticians call a sample. There are three conditions that any argument using non-universal generalizations must meet in order to be acceptable. First, the sample size must be sufficiently large to justify the generalization. The greater the sample size, the more probable the inductive inference. Second, the sample must not be biased. Ideally, the sample will be randomly selected, which simply means that each member of the subset of the total population has an equal probability of being included in the sample. And third, the sample must be representative, which means that the sample reflects the characteristics of the total population. Here's an example based on our text. If I were determining the relative proportion of cars to trucks that drive down my block on a given day, the population would be the total number of cars and trucks that drive down the street over 24 hours. And if I were to sit on my stoop from 9 a.m. to 1 p.m. and count all the cars and trucks that drove past me, that would be the sample. A good sample is representative of the population. When a sample is representative, the characteristics of the sample match the characteristics of the population at large. So, my method of sampling cars and trucks that drive down my street would be a good method as long as the proportion of trucks to cars that drove down the street between 9 a.m. and 1 p.m. matched the proportion of trucks to cars that drove down my street during the entire 24 hours. If for some reason the number of cars that drove past me from 9 to 1 was much higher, say, than the average for the whole day, my sample would not be representative of the population. And how do we obtain representativeness? By enforcing the adequate sample size condition and the randomness requirement. If we get a large enough sample that's been selected without biases, that is, randomly selected, we'll have a sample that's representative of the population at large. In our next unit, we'll examine another form of inductive inference, namely causal reasoning. We'll find that its use in the sciences is absolutely indispensable. Until then, best wishes.